So let us take one numerical. Say we are asked to show in this way. In the dimensional analysis problem, the statement is like this: show that, for example, show that what t is equal to d raised to 5 n raised to 2 is n square into rho, okay, is function. This is a function, is phi, function of mu upon d square n rho. This means we have to show this. We have to show this expression. So how to do this? So solution, we will first of all simplify this. See, this we can write in the left side. See, t divided by these three quantities. If we take left side, then we will get here ratio t upon d raised to 5 n square rho is equal to 5 of mu upon t square n rho. Okay. Now you observe this carefully. Here, this is one dimensionless number. Means it is one pi term. This is a group of properties. How many properties? 1, 2, 3, 4. 4 properties together becomes one dimensionless number or term, that is pi term, which is a function of another pi term, say pi 2. This pi 2 term is again group of these 4 properties, mu, d and rho. Means here we have to identify how many number of terms? 2 pi terms. We have to find 2 pi terms. 2 pi terms. Means our final objective will be what? Pi 1 is equal to, we will get t upon d raised to 4 n square rho. This pi 1 term we will get in this way. Okay, and pi 2 term we will get, that is mu upon t square n rho. This we have to find by using Buckingham pi theorem. Okay, now how to find? So that is, we start first. We have seen that in Buckingham pi theorem, here is a which term which is depending on all these parameters, that is a t. T stands for torque. We have seen all these parameters. T means what? Torque. So T means torque, which is depending on all these parameters. That is a function. Torque is a function of how many parameters? All the remaining parameters, excluding t, is for d, then n, okay, rho, d and rho, mu, okay, d already came, okay, d already is here, then n is already again here, okay, rho. So d and rho, these are already here. These are diameter, speed, density and dynamic viscosity. Okay, so now we will write this way. T is a function of d and rho and so this is the general way, but here we have to write in this way. T is a function. Now this function why we wrote, because here in the expression function is indicated by phi. So that is why we have to write t is equal to phi of d and rho mu. D and rho mu. Okay. Now here, how many total number of variables that we write in this way? Phi is function of all these variables. T is torque, diameter, speed, density and viscosity. okay, is equal to 0. Now this is what first Buckingham pi theorem statement, what we have written. Okay. Now here you can measure in this how many number of variables? 1, 2, 3, 4, 5. Means n is what? 5. Total number of variables are 5. Total variables are 5. Now out of these 5 variables, we have to select how many variables? 3 variables which are repeated variables. So see here we will write first of all, we will select here which 3 variables. Okay. So from these 5 variables we have to select 3 variables which repeated. Now what is the rule for that? We have discussed. One should be dimensional, means geometric property. One should be flow property, and one should be what? Which property? Fluid property. So you can take dimension means geometric property as a D. We can take N as a flow property, and you can take rho as a fluid property. So here M is equal to 3. These are which? Repeated variables. Repeated variables, which are in the bracket diameter, speed and density. Diameter, speed and density. Okay. Now n minus m means 5 minus 3 is equal to what? 2. This 2 will be what? Number of pi terms. These will be what? Pi terms. So here will be 2 pi terms. Already we have this 2. One is a pi 1, another is pi. So 2 pi terms we will be having here. So we have selected these 3 variables, okay, repeated variables. Pi terms will be 2. So we can write that pi is a function of pi 1 and pi 2. So we can write pi is a function of pi 1 and pi 2. In this way we can write this equation. This equation is fundamental equation, we can write in this way, pi. Now how to write pi terms? How to write pi terms? Okay. So before writing the pi terms, we will need MLT form of all the variables. So let us enlist MLT form. So for torque T, already we have seen torque. Torque means Newton meter. So form we have derived, that is ML square, ml square p raised to minus. Already we have done this. Okay. So you should know this torque. Then diameter. Diameter means meter. So its form will be M, capital M. Next is a speed. Speed is what? Per second. Per second means p raised to minus 1. P raised to minus 1. Density rho. Its form we have taken, that is M L raised to minus 3 and L raised to minus 3 kg per meter cube. Kg per meter. So T, D, N and rho. And finally we need viscosity, dynamic viscosity. So dynamic viscosity, Newton second per meter square unit, and its form we have already taken, that is what we have derived, that is M L raised to minus 1 T raised to minus 1. So these 5 forms we will enlist first of all, that we need. Now we will write pi terms. So let us write pi term. first term is pi 1. Pi 1. How to write pi 1? I already mentioned. Pi 1 means first you write that x2, x3, x4 repeated variables. x2, x3, x4 means what we have taken here: diameter, speed, and density, d and rho. Okay. Raised to, you have to write a1, b1, c. Okay. Pi 2 term. In that again these fundamental variable will come, d and rho. Exponent will be a2, b2, c2. Okay. Now we have to multiply here with remaining variable. What is remaining? One is a torque, and another is dynamic viscosity. Torque, dynamic viscosity. So d and rho multiplied by one torque, another term multiplied by mu, and right here one exponent, because we have to now equate these exponents. Now next, first we will take this one by one. We will solve. We will take this first of all pi 1 for the solving. So let us take first pi 1 is equal to d raised to a1 m raised to b1 rho raised to c1 t raised to 1. Now we have to write this in MLT form. Okay. Now what is the next step? MLT form. So pi left side m raised to 0, l raised to 0, t raised to 0. Because we have to now solve. How to solve? The method is like this. For the pi 1, it is a dimension less, no dimension. No dimension, that is why exponent is 0. No dimension of m, l, t. Every dimension 0 means m raised to 0, l raised to 0, t raised to 0. Here at d, we have to write form t. Which form? D, this form. D is what? M. Its form is not m actually, its form is L. It is a length, not mass. Sorry for that. It is a L. Okay. So in this way, L will come. L raised to A1. Speed. What speed? This is the form. T raised to minus 1. T raised to minus 1. Exponent V1. Then rho. Rho. Form is where ml minus q. M L raised to minus 3. This is the form. MLT form. Raised to C1. Multiplied by torque. This torque. What is the form? Torque ml square ml square t raised to minus 2. So in this way we have to write all these forms in the bracket. Method you will understand. Okay. Pi 1 d and rho into t. Pi 1 term in MLT form, d term in MLT form, d and rho t. Already we have taken from this d and rho and t. MLT form. We have written in the bracket. Here exponent a1, b1, c1. For the torque exponent 1. Now what is next method? Now we have to equating powers. Next is what? Equating powers. Equating powers. Powers of m, l, t. We have to equating powers. We will find equation. How? See, for m, equating all the powers of m. So we will write in this way, m. Okay. How to write? See, what is the exponent of m? Left side 0. 0. Here, whatever are the exponent of m, that will come. In other, 0 will come. Means here is no present of exponent for m. So 0. Plus, here no exponent for m present. 0. Here, exponent of m is 1. Here is not written, but m raised to is what? 1. 1, we have to take this 1 and this C1 product. What I am saying? Product. So it will come C1 plus here exponent 1. 1 into this 1. Product of these both exponents will be what? 1. So in this way we will get one equation. Okay. From this equation, by solving this equation, what will come? C1 is equal to minus 1. Understood? 0, 0, 0. C1, this one other side will come. C1 is equal to minus 1. This is the way of finding the value of exponent. We got now here in the first C1. Later on we may get value for B1 or A1. How? Let us see. Now this is for M. We have to write now for L. For L. How to write L? See, left side L. Exponent is 0. See here. For L is present. Yes, L is present. What is the exponent? 1. 1 into A1 is A1. Plus here L form is no present. 0. Here third L raised to what? Minus 3. Minus 3 into C1 means minus 3 C1. Okay. Plus for L, here is a 2 present. 2 into 1. So solving this, now here, see, we have two variables. So it is not possible to find now. So let it be this equation as it is. We will go for T. We will find here value of A1 or C1 here. Then we will put that here. Isn't it? So for the T, same way, do for T, left side 0, right side no present T, so 0, plus here T is present, minus 1 into B1 means minus B1, plus no present, T form no present is 0. Here T form is present, product of minus 2 into 1 is minus 2. So here minus. So here by equating this or by solving this, what will be value of B1? B1 will be equal to minus 2. Isn't it? B1 will be equal to minus 2. See, now we know B1. We know C1. So we can put value of C1 here. Okay. And finding the value of this. So A1 minus 3. Value of C1 is minus 1 plus 2. Now C properly is equal to 0. So minus 3 minus 1 is plus 3. Plus 3 plus 2 means plus 5. Plus 5. A1 plus 5 is equal to 0. Means A1 will be equal to what? Minus 5. Remember, A1 will be equal to minus 5. So we got the values of A1, B1, C1. After getting these values, what we have to do? We have to put these values again at the base form. So here base form is, write the base form. Pi 1 is equal to B1 raised to A1, N1 raised to B1, rho raised to C1 into T. Okay, so putting the values of A1, B1, C1. So D1 raised to what D1? It is a D. Okay, D raised to A1. A1 is what? Minus 5. N raised to B1. B1 is what? Minus 2. Rho raised to C1. C1 is what? Minus 1. So pi 1 will be equal to, now properly you will get value T. See, all these are having exponent negative. So these negative exponents, if we will write at the denominator, will become positive. So here we can write D raised to 5, N raised to 2 and rho. Now you can observe in your earlier page, you will find that pi 1 term already have obtained in this. So in this way we got pi 1 term. That is your half answer. Similarly, we will follow the method for pi 2 term. Let us write pi 2 term. Pi 2 is equal to d raised to a2 n raised to b2 rho raised to c2 into mu raised to 1. Let us write MLT form on the left hand side and right hand side at the respective place of the variable. Already we have done this. Only we have to change with the exponent. Yes. So in this way we have written, see, L raised to a2, L raised to, there is no means, there is nothing means 1, L raised to 1, A raised to minus 1, M raised to 1, wherever our exponent upside there you consider as a 1, because we have to equate, we have to take multiplication of exponents. Now we have to write 3 equations. How? By equating powers. Equating powers of m, L, t. Let us write for m. For m, writing for m, left side 0, right side here is no present, here is no present, here is present 1 into c2 is c2, here is present 1 into 1. Okay. By solving this first equation, we will get c2 is equal to minus 1. Minus 1. C2 is equal to minus 1. Similarly, we will do this for L term. For L, left side 0, right side C, L is a present. So 1 exponent, 1 into a2 is a2. Here, L is length is not present, 0. Here is a present. So L raised to, this is what minus 3 C2. Minus 3 C2. Here, minus 1 into 1 means minus 1. Minus 1. Okay. Now in this case, C2 value is minus 1. So putting this value here or using this value here, minus 3 into minus 1 minus 3 minus 1 means plus 3. Plus 3 minus 1 means plus 2. A2 is equal to minus 2 will come. A2 is equal to minus 2. We get A2 is equal to minus okay. 40 right term, 40 left side 0, right side here is no present t 0. Here is a t raised to minus 1 means minus 1 into b2 means minus b2. Here is no present t, so 0. Here t raised to minus 1 into this 1 minus. Solving this, we will find b2 equal to minus 1. So we got values b2, a2, b2, c2. We got values of a2, b2, c2. So putting these values, values of a2, b2, c2 in the upper equation, that is pi 2 equation. So A2 value is how much? Minus 2. B2 value is minus 1. C2 value is minus 1. Into viscosity. Here. Pi 2. So here pi 2 term will what? mu, okay, and these three terms we will write at the denominator so that their exponent will become positive. So here d square and rho, d square and rho, d square and rho. So we got this phi 2 term. Phi 2 term is d square and rho. Now we will write this phi 1 on the phi 1 term. See, already we know that, as already we have seen, as we have pi 1 is a function of pi 2. Pi 1 term is a function of pi 2 term. Okay, so write in this way, pi 1 term we already obtained, that is t upon d raised to phi u and square rho. This is pi 1 term, which is a function of pi 2 term that we obtain, that is mu upon d square and rho. So we have to write in this way. One term is a function of other term. One term is a function of other term. Now finally we can arrange now this torque. Only torque we will keep one side and the all terms we will take right side. So right side if you take, it will come d raised to phi and square rho. Okay. Phi is function of mu upon d square and rho. This is what asked to do. So we can say thus it is verified or proved. It is verified or proven. This equation is proven.